what you're looking at here is the user interface for Cast Highlight. And Cast Highlight, as we said, is a SaaS product that captures information in a couple of ways. First off, we're automatically analyzing source code via various options and tools to plug in the source code, but all that analysis happens locally within the client's environment. And then we're also capturing a couple of additional qualitative pieces of information via a built-in survey. Those two inputs, once those are made available here in Cast Highlight, that drives all of the reports and dashboards that you're about to see, right? And the first thing that you might notice is at the top of the screen, you've got these 4 colored tiles here that represent our 4 main categories of insights or software intelligence that you can get out of Cast Highlight. So software health, very much focused on things like the resiliency, agility, complexity, or technical debt associated with a portfolio of applications. Cloud readiness is measuring and providing insights around how ready is an application to move to the cloud and be deployed in a PaaS environment or be cloud native. And we'll provide insights on what are the blockers to migrating to a cloud native state, measure or estimate the effort. Open source safety is where we'll focus today. This is software composition analysis. That is measuring open source risks associated with security vulnerabilities, risky licenses, obsolete components, and things of that nature. And then finally, green impact is our newest area of insights that's measuring how sustainable is software, a portfolio of applications, or an individual piece of software based on the patterns in the code that are correlated with excess resource utilization or ultimately more energy consumption. So in this area, you get recommendations on essentially how to make your software greener, use less energy, etc. So the example we're going to walk through is a portfolio of 220 applications, so a small portfolio. And we're going to start by drilling into this open source safety tile. Now, you'll see this number here. Most of the numbers that you see in Cast Highlight are calculated on a scale of 0 to 100, right? We calculate those at the application level individually, and then we roll those up into a portfolio level score. So the first thing I'll mention about Cast Highlight from an SCA perspective is that we have this unique calculation or aggregated score we call open source safety that combines the risks associated with security vulnerabilities, risky licenses, and obsolete components into one score. Now you could drill down and look at those individual insights separately, but here you can get very quickly a snapshot on an entire portfolio of applications. What's my open source safety score across all those different types of risks? And in this case, for this portfolio, it's actually pretty good. It's 89.4, but you'll see the worst score in the portfolio, you'll see the best score, and then you'll see the industry average, because we have a benchmark where you can compare your applications in your portfolio with an anonymized benchmark of applications from lots and lots of different companies and organizations. All right, so let's click into open source safety. And that's going to bring us to one of our portfolio level dashboards that we call the Portfolio Advisor for Open Source. Now in Cast Highlight, we have a few different types of what we call portfolio advisors for different purposes. We have one for cloud, we have one for green, etc. This one is all about providing automated guidance and recommendations on how to reduce my open source risk. So in this case, what we're doing is we're automatically looking through the entire portfolio of applications. We're looking at the risk levels, security vulnerability risk level, license risk level, obsolete or age or operational risk level. And then we're also overlaying that with things like the business impact of an application that we capture via a survey. So that's more qualitative information that we're overlaying on top of the automated fact-based technical information coming from analyzing the applications. And what that allows us to do is make some very actionable recommendations across applications. Now, as you can see here, here's a list of applications represented by each of these bubbles represents an application. That's not all 220 applications in the portfolio. What we're doing is we're identifying the applications that you need to take quick note of from an open source risk perspective, and it's not the whole portfolio. So very quickly, we're all automatically reducing the amount of noise that could be caused by having a very large portfolio. And we're telling you, here's the applications you want to focus on taking action on. So down here, we have what we'll call 6 different actions or segments of recommendations, if you will. I could also see the full list of applications here and see additional data and insights. But just to give you an idea how this works, we've got 5 applications where we're recommending immediate attention. These are the applications where there's flashing red lights. There's a lot of issues with these applications. They probably have security vulnerabilities, risky licenses, very old components, you name it, and they have a high business impact score. So that's why these applications are immediate attention. So if I click on that segment, I'll see here's the 5 applications I really need my team to look at very closely right away, because those are the riskiest applications. Okay. I have 10 applications where the priority action is to fix the security vulnerabilities, right? So maybe these are critical business impact applications, but the biggest issue from an open source perspective for them is the CVEs or the severity of the vulnerabilities that were found in them. I have another segment here of 3 applications. This is for the legal team to look at, right? So now I've got a segment here where I could say, hey, my compliance, my IP, my legal team, here's the 3 applications you need to look at very carefully. So again, a very interesting scenario where I have 220 applications. I don't need my legal team to go through all 220 necessarily. I give them immediately the 3 they should look at first. And these are the 3 applications that I need my legal team to spend some time looking at. What are the licenses being used in these applications, because they're kind of risky. And finally, for my development team, I have 13 applications where they're using old components, right? So these are critical. The components are old. Let's look at upgrading those components. I have 6 applications. These are applications that are less important to the organization, so lower business impact, but they still have some issues. So we put those a little bit further down the list. You might want to consider looking at alternate components there. And then finally, we have a very interesting category or segment here called role models. There's 2 applications where they actually are doing really good work. All of their scores, their open source safety scores, are very high. So they're using safe components that have low security risk. They're using licenses that don't pose a lot of legal risk to the company, and they're not using out-of-date components. They've been good about keeping them up to date. So here's a couple of applications where you might want to look at what components are these teams doing? What is this team doing differently such that their applications are really reducing the risk to the company? So that's an interesting area. Now, we know that even though Cast Highlight automatically recommended these actions to take, they might not always be the perfect recommendation. So we give users the opportunity to change the segment they're in. So for example, for this application, they want to actually move it to the fixed vulnerability segment. They can do that, they can save that, and now you've just in real time moved one application from the upgrade components to fixed vulnerability segment. And if you ever want to understand how any of this is calculated, you could click on this little icon next to any of the applications, and it'll actually bring up what the numbers are that it got in each of these segments. And it'll tell you what the formula is that we're using to actually calculate the score and then recommend that this be a fixed vulnerabilities action to take, right? The reason we do that is this entire model that I'm showing you here, even though it's out of the box like this, it's completely customizable. So our end users have the ability to not only customize this model, like change the formulas, change the segments, rename them if they want, change the weightings of how things are calculated. They can create their own portfolio advisor. So maybe they want to use this as a template, save it down, modify things, republish it, and now they have their own portfolio advisor with their rules, with their methodology, or however they want to use it. So that's why we expose all of the formulas and calculations. Okay, so that's kind of a portfolio level view. We do the same thing at the portfolio level for all the components in use. So here is a view with every single component or open source library we've detected now across the portfolio available here. And we show every component, whether it's on the allow or deny or being reviewed list, where it comes from, any weaknesses, CVEs, the license in use, etc. which applications it's being used in. And I'll give you a very quick, simple example of how powerful this is. So a little bit over a year ago, when there was that issue with Log4j and a component that had that severe security vulnerability, and it was impacting a lot of organizations, our clients were able to quickly come into this component view, simply type in Log4j, and lo and behold, here they were able to open this up, see the component here, and they could see instantly which of their applications across their portfolio were using Log4j, what version was in use, and what were the vulnerabilities. So literally in a few seconds, our clients were able to identify and evaluate the issue that they were dealing with when it came down to Log4j, and immediately identify which applications were impacted, especially by the version of the component they were using. So that's a very powerful thing, that because we take that control tower view, when something like that comes up, it is that much easier and more actionable for them to come in and understand what they need to do to address a very risky situation like that Log4j, the situation that came up. So similar to component level, we provide insights across the portfolio for vulnerabilities. We also show the weaknesses. So again, this is our open source software intelligence database where we're analyzing the most popular components, the actual source code, because it's available publicly, obviously, of the most popular open source components, and looking for weaknesses. And then we expose those weaknesses in cast highlight. So these are possible future vulnerabilities or CVEs that have not been reported yet, but we are reporting them as weaknesses in the product. And I could see, which components are impacted by each of these weaknesses. I could open them up, and then I could see what applications might be impacted. We also have a license view across the portfolio. I talked briefly before about our open source license rulebook. So if you click on any license in Cast Highlight, for example, we have a license here that's being used by 33 components. If I open that up, here's the license text. As you can see, it's quite long, a lot of legal language. But what we've done in Cast Highlight is created this rule book that automatically interprets that text into this user-friendly, color-coded rule book. So it shows you what does the license allow legally, what doesn't it allow legally, what must you do if you have this license, and what additional properties are associated with that. So now, again, this is never going to replace consultation with a legal expert, an IP compliance expert. However, for many of us that are not, IP compliance legal experts, this gives us a very quick snapshot onto the requirements and legal constraints of a license without having to read through text and try and interpret it on our own. So that's available out of the box in the product. And then finally, I'll show something very new in the product. It's called proprietary component governance. And essentially what we're doing here is, now it's almost like the inverse of open source or SCA. We're using our engine to automatically detect proprietary or internal components that an application or portfolio is using. So if clients are trying to determine where are certain components that they've built in-house being used across their portfolio, they can use this. If they're trying to understand, are my development teams adopting the latest version of our proprietary library that we want them to use for whatever purpose, they can see which applications have adopted the correct version. They could identify if there's components in use that they'd like to share across the organization because some team developed a really cool library or component that would benefit other teams, for example. So very quickly how this works, let's say also I could use it to look for a commercial or licensed component. Let's say I want to see all of the Microsoft components that are in use across the portfolio. I can see automatically which of those that our development teams are referencing in their applications. I can go ahead and open that up. I can see that this one's being used by 3 different applications. I can go ahead and edit that. I'm going to then label it as a proprietary. I'm going to label it as this one's allowed. I'm going to put a tag on it called licensed. and I can just add, a little note there. I'll save that. And now I actually have a little tag here, so I could actually filter my components and search for them based on license. So as I go through and start cataloging my proprietary components, I now have a very useful inventory that I could use for various use cases related to using proprietary components. Okay, so now let's drill. Everything I've shown you just now has been at the portfolio kind of control tower view, but obviously you need to get into an application at a certain point. So let's go down to one application. I'm just going to search for one that I know is pretty good to look at. So now we've left the portfolio level view and we're down at this individual application. It's called experiences, right? Now, we're doing a lot of the same things here at the application level that we're doing at the portfolio level. You'll see a lot of the same scores and insights and metrics. You'll see different types of insights you can get around health, trending, cloud readiness, green impact. Here's our benchmark. But let's focus in here on software composition. So if I click on that tab, again, I'm at the application level. I'll be presented with a very quick summary screen on here's all the security vulnerabilities that have been detected across the products. So we detect both CVEs from the National Vulnerability Database. We also detect advisories from the GitLab advisories community. We'll summarize the license issues. So there's 2 risky licenses here. And then we'll list all of the components detected in this application. And you could view that kind of with a vulnerability view. You can view it with a licenses view. You could view it with an obsolescence view that's more about how old or out of date is a component, or you could just view everything on one screen, right? So if we take a look at the vulnerabilities view, for example, here's that log4j component here. But a good one that actually works out quite well is this component right here. So if I click on that, that'll bring up a little timeline. I'll see that I'm currently using a quite out-of-date version from 6 years ago. That's a bit of an extreme example, but it's a demo. And I'll see that it has a critical vulnerability. And if I scroll up this timeline, I could see at some point in the history and timeline of this component that vulnerability eventually was removed. And it still has some, medium severity vulnerabilities there. And at a certain point, I start to see much cleaner versions or safer versions. Now, if I start upgrading this component to something that's, in a much closer time to now, I see all the vulnerabilities have been removed. We have an automated recommender built into the product now. So I see here that I'm currently using version 3.0.11. If I come over here, I could see automatically I'm getting 2 recommendations. I'm getting safer and closest and safest. And what that means is sometimes if I wanted to go to the safest version, going from 3.0.11 to 3.18, that might be such a huge technological shift. That's too big of a leap to make right away. So what we're doing is that would technically be the safest version. But if it's too hard to go directly to there in one jump, we're going to recommend the safer and closest version that's probably technically easier to get to. And then over time, I can go to the safest version. So that's how that safe component version recommender works at the application level. So again, we have that built across the application portfolio and down here at the application level. This is a great example because this application has 156 components. And one of the reasons that is useful is, let's say I want to actually do a comparison from one snapshot to another. I can click on this compare components. I can click on an old scan of the application and a more recent scan of the application. And here I can see what has changed from one scan to another. So do I want to see how my development team is doing in improving and reducing my open source risk? So I could see how have the individual scores improved, over time. How has the vulnerabilities changed over time? I could look at, for example, I could filter this unchanged. So which components have changed? I don't have any. Which have been added? I don't have any there. Some might have been removed, so I could actually see that as well, or updated. And then here I can look at the actual updated components what CVEs are introduced, the version, et cetera, et cetera. So this allows me very quickly to do a comparison and understand what's actually changing from scan to scan, and that what's driving the changes in my scores, if you will, when I log in one day or one time versus another time. Okay. I also have the ability to download and view the bill of materials. When you click on that, we have different options. We have an Excel option, which is more, your traditional Excel file with all the data about a bill of materials. We support Cyclone DX. So if I want to integrate this data in a more automated fashion with other systems or tools, Cyclone DX is an industry standard XML format for transferring software bill of materials or SBOMs. And then I have a Word version, which is really designed more for that legal audience. So if I want to essentially transmit or download an SBOM that's more focused on the legal risk, the licenses and use, et cetera, and have it be more of a readable document for a legal audience, that's what the Word export is. So I can export that and view that. I can very quickly show you, for example, what the Excel file looks like. So here's the software bill of materials that's exported by Cast Highlight in an Excel format. We've got our detected components with all the data that you saw. This is for that one application that we were just viewing directly in the user interface. I've got my dependencies and the various other elements. You'll see different tabs here. All the data that we were looking at the user interface is available in the software bill of materials. And there is one final thing I quickly wanted to show. So we also have a connector to Jira. So basically, this is an out-of-the-box plugin available for Cast Highlight. So this is an out-of-the-box plugin available for free for all active Cast Highlight subscriptions that lets you connect all of your Cast Highlight data directly into Jira. Right. So basically, all of the insights that we were looking at in the demo that we were just showing in Cast Highlight, you could push the useful information. For example, I'm going to pick that same application we were just looking at out to Jira, and that's going to pull in things like cloud blockers. If it's more of a cloud readiness situation, it's going to pull in all the vulnerabilities that were detected, and I can select which ones I want to address. Maybe I just want to address these two critical ones, so I could unselect the others. And I can go ahead and create a vulnerability issue. That creates an issue inside of Jira. I could assign that to the team. And then now I've pulled my actual data out of Cast Highlight and turned it even more actionable because I'm pushing it right into my ticketing system so that my development team can start addressing those issues directly in Jira. So again, just as a quick summary, Cast Highlight is designed to be a control tower for your application portfolio. From an SCA perspective, we'll give you insights at the portfolio level across all your applications, make automated recommendations, identify all the components in use, the vulnerabilities, licenses, which applications are using them, let you search and implement policies for controlling your components, your proprietary components. We'll let you set those same types of policies for open source components. I just didn't show that in the demo. Then you could drill down to one application, understand the actual risks, vulnerabilities, license risk, obsolete components at the application level, and then take action by pushing that information to other places by either exporting a software bill of materials or using our plugin for something like Jira to push those insights directly into Jira and create those tickets and assign those issues to a team. So that gives you probably a pretty good overview of the capabilities of the product from an SCA perspective.